How secure is an SSH tunnel or connection? I have often advised people to use an SSH tunnel to secure their browsing on open Wi-Fis or in other insecure situations. I was recently asked by a friend how secure a SSH tunnel is after I had suggested SSH tunneling. I stumbled a bit and reiterated it's secure. Even though he was satisfied with this answer, it bugged me a bit that I couldn't fully answer. So the question goes out to you guys. How secure is an SSH tunnel?
I'd just like to quote a little from Wikipedia here. Even if a symmetric cipher is currently unbreakable by exploiting structural weaknesses in its algorithm, it is possible to run through the entire space of keys in what is known as a brute force attack. Since longer symmetric keys require exponentially more work to brute force search, a sufficiently long symmetric key makes this line of attack impractical. With the key of length n bits, there are 2 n possible keys. This number grows very rapidly as n increases. Moore's law suggests that computing power doubles roughly every 18 to 24 months, but even this doubling effect leaves the larger symmetric key lengths currently considered acceptably well out of reach. The large number of operations, 2,128, required to try all possible 128-bit keys is widely considered to be out of reach for conventional digital computing techniques for the foreseeable future. However, alternative forms of computing technology are anticipated which may have superior processing power than classical computers. If a suitably sized quantum computer capable of running Grover's algorithm reliably becomes available, it would reduce a 128-bit key down to 64-bit security, roughly a day equivalent. This is one of the reasons why ICE supports a 256-bit key length. See the discussion on the relationship between key lengths and quantum computing attacks at the bottom of this page for more information. So a 128-bit key would have 340 undecillion 200 and 82 decillion 300 and 66 nonillion 900 and 20 octillion 900 and 38 septillion 400 and 63 sextillion 400 and 63 quintillion 300 and 74 quadrillion 607 trillion 400 and 31 billion 768 million 211,456 possible permutations. Imagine going through all those. Even a powerful desktop computer can only try a few per second. So although it's theoretically possible to brute force decrypt an SSH stream, by the time the key has been decrypted by the most powerful computer imaginable, 2 things would have happened. The key would have been changed by SSH. We would all have died and the sun exploded and destroyed the earth.
And LT, disclaimer, not an expert on cryptography and GT. SSH v2 uses mostly the same algorithms as TLS/SSL. DH, recently ICT or RSA for key exchange. RSA, DSA or ICSA for server authentication, and very often, client authentication. ICE for symmetric encryption, the entire data stream is encrypted using a randomly generated key. All of them are widely used and proven secure for everyday use. However, in any protocol, security depends on knowing that you are communicating with the right server. In the case of SSH, standard configuration, the first time you connect to the server you have to verify its fingerprint. Don't just confirm it without actually checking, as many people do. The next time, the server's key will be checked against a cached copy to prevent man-in-the-middle attacks, but only if the right key was cached in the first place. In comparison, TLS/SSL handles the above by using X.509 certificates issued by well-known authorities, which are trusted to not sign bogus certificates.
If you want to support the channel, please consider subscribing.